you gotta think about the pH. The first thing that should come to your mind when you see that pH is what? It's in the normal window, right? So if we got problems here, we can at least say this is, no, what do we say just by looking at that? Compensated. Like if we got problems, okay, if all these are normal, it's just a normal patient. The PCO2 is 70. Is that normal?
No.
Oh, it's increased. Alright, don't jump the gun on me. Hold on. Alright. You are faster than me at this. I don't know about you, I gotta think through it. Bear with me. Okay, HCO3.
That is
It's elevated.
It's also elevated.
But is it elevated because the other one is?
Okay. Probably doesn't say this in the book, but I want you to look at that. If you're looking at 7.36, just tell me this. If you had to go one way or the other, is it leaning toward acidic or is it leaning toward alkaline? Acidic a little bit? Okay. So, you guys tell me, what do you think is going on with this?
I think it's respiratory acidosis.
Think it's respiratory acidosis?
Recovering from respiratory acidosis.
It's with compensation.
Okay, well, let's try it. I'm gonna write down respiratory acidosis and let's talk about it, okay?
Okay.
All right, so. So, respiratory acidosis. If our PCO2 is increased, all right, you agree that makes the blood acidic, okay? Even though we're in the normal range, but it's toward acidic, okay? Now, one thing I look at that, when I look at the PCO2, that's almost double what the normal range is supposed to be. It's way up there, right? Okay, so it's tend to making me think respiratory acidosis, but what about, this isn't like one of the normal ones we were doing before. Why would the HCO3 be 32, which is a little abnormal too?
Because it's compensating.
What's compensating?
Metabolic.
Okay, which is what?
Bicarb.
Bicarb's compensating, good, Kennedy, okay, but what?
Bicarb is alkaline, so it must have been acidic if the alkaline's compensated for it.
Okay, so I'm just gonna go ahead and tell you, this is respiratory acidosis, but I want somebody to explain to me why the bicarbonate is increased. Not just it's increased, somebody tell me, why is the bicarbonate increased?
Because it's trying to.
CO2 was so grossly increased.
Say that again, Catherine.
Because the CO2 was so grossly increased.
Okay, I agree the bicarbonate's increased, I'm wanting you guys to tell me what body organ is responsible.
Kidneys.
Okay, so the kidneys are doing what to the bicarbonate? It's important you tell me the right word. Holding on to it, I take that, okay?
Holding on to hydrogen.
It's reclaiming it, it's reclaiming as much bicarb as it can, and it's probably voiding off hydrogen ions as well. So in other words, we have since this is technically in the normal range, we would call this compensated respiratory acidosis. The person went into respiratory acidosis. Now remember, that means, okay, respiratory acidosis, they're not breathing very well, okay? They're keeping that carbonic acid inside their lungs and in their blood, okay? So it's acidic. And so the body is compensating by reclaiming as much HCO3, even if it has to go abnormally high. If the blood's real acidic, you better put some more alkalinity in the blood, okay? So the body's reclaiming the bicarbonate, which is going to buffer it, all right? And that's going to be compensated respiratory acidosis. And the only other question I'm going to ask you about it is this going to be a quick compensation or is it going to be over the long haul? Right. If the body compensates through the kidneys doing something, it takes a while, okay, for the compensation to go to be fully activated where it goes into full compensation. But if it compensates through the lungs, like hypo or hyperventilating, it's quick acting. All right, yeah.
And in that scenario, it would be a metabolic problem.
Yes.
Okay.
So this patient is in respiratory acidosis, but it's called compensated respiratory acidosis because the kidneys are compensating by reclaiming the bicarbonate and probably excreting out any excess hydrogen ions. Alright, I'll give you guys a note.
Positive is acidosis.
What?
Yes.
Positive is what?
That's why the bicarbonate.
You can always,
It is acidosis because the pH is teetering for. Yes.
Well, the other thing though is if you think about it this way, if your HCO3 is truly increased, if this was the culprit, it's gonna be alkaline.
Yeah,
You see what I mean?
yes.
But it's not.
Why? They're both up, the respiratory and metabolic.
They are both. But if this was the culprit, okay, if this was truly increased, there's no way the pH would be sitting kind of toward the acidic side.
oh,
It would be more like 7.44.
she could also do the math, and the math should prove that it's
The
acidic.
math should prove it, but
Yeah.
it has to, in other words, it has to make sense. There's no way the HCO3 can be increased and this be this toward the low end. It would be elevated.
That's why it's
It'll be on the high end of normal. I need to see the math proof it, I'm sorry.
Well, the math comes out to 14.74.
Yeah, cause we
I
already did
don't
the
know
math.
that the math on this, because once the body starts compensating,
Test question.
if I ask you the math, it's gonna be on a patient where I give you an abnormal, a normal, and the pH.
You're not gonna like do.
No, I wouldn't do that. This is a question where I'm wanting you to think through it,
Okay,
okay? And we're fixing to do another one, just like it, okay?
It's only because the compensation is reduced. If nothing happened yet, then you get ready. The bicarbonate still get there.
I don't have to reevaluate more, he agrees.
Alright, so we know this is normal, right? 31 for the PCO2 is what?
low,
18 for the HCO3?
low,
Oh.
We just changed that word.
How do you say that? Respiratory alkalosis with
Compensated. Alkalosis is compensated. Metabolic.
alkalosis.
If you have to go one way, where are we going? Acid? Normal range 7.35.
Well, it's closer to, yeah, you're right.
yeah, that's closer to acid.
Closer to
What'd you
acid.
say, Darren?
I'm thinking metabolic acidosis with
Yes.
compensation.
Yes, okay, but let's talk about it. Let's get through it. Let's say metabolic acidosis. Okay, so it's compensated because it's within the normal range now. But we're gonna go metabolic. Metabolic, as far as the HCO3, that has to do with metabolic, that's low, okay? The PCO2 is also low. It's metabolic acidosis and the body is compensating. What can make the CO2 go low?
Breath, breathing it out. Yeah.
Hyperventilating. The patient is in the process of hyperventilating, okay? So they're blowing off the PCO2 to catch it up with the low HCO3. This is compensated metabolic acidosis, and probably this patient is in the middle of hyperventilating. Let me check my work, make sure I'm not telling you guys wrong. Okay, this patient, according to the book or to the reference I got this from, was administered too much of an acid-producing substance, okay? And it says compensation probably occurred through hyperventilation. It cannot be respiratory acidosis because the PCO2 would have to be increased. see what I mean? For this to be acidic, the PCO2 would have to be way high, right? To cause acidosis, your partial CO2 has to be increased. So that's which way that should lean you there. Yeah,
Okay, so let's say the PCO2 was in a normal range.
okay, let me do that. Has everybody got that written down, that example? Okay.
Same with all, yeah, just everything the same except the PCO2 is normal 4.
I spelled hyperventilating
Alright.
wrong, sorry.
Would this still be metabolic acidosis just without compensation?
Nope, you know why?
I'm listening.
Because the pH is in the normal range now.
It just still hold.
Yeah, if I gave you this, if I give you a question like this, okay, I have to, let's do something real quick. With these values like Darren's going off of, you guys tell me, if the HCO3 is low, okay, and the PCO2 is high, what can that be? Respiratory what? Why are you saying acidosis? You're right, I just wanna know why.
Because CO2 's high.
The PCO2. Remember, guys, if this helps you guys, I don't care, I want you to get the answer right. I want you to remember, this, okay, represents alkalinity if it's too high. This represents acidity if it's too high. Partial CO2 represents acidity if it's too high. Bicarbonate represents alkalinity if it's too high. Is that making more sense?
Well,
to
no,
you?
I remember what I'm not doing on my other method. I didn't flip. So, it's okay, go on with your.
If the partial CO2 is high, okay, which is 40, well, actually, this is normal. Okay, this is normal. I told you guys wrong. I just told you guys wrong. Aaron?
Yes, sir.
Alright. Okay, if the PCO2 is normal and the bicarbonate is the only thing
That's not
affected,
true.
this is a metabolic problem. Metabolic. Metabolic, everybody with me on that? It would be metabolic. The HCO3 is low. Okay, the HCO3 being low, that's going to be metabolic. It doesn't work out that way.
I feel you.
Yeah, it's gonna be metabolic acidosis.
God damn it, Cody.
Because the PCO2 is normal, but in relation to the HCO3 is too low, which means relatively you got too much acid, so it would be metabolic acidosis. Yeah.
Now my question is this metabolic acidosis? But is it without compensation?
Well, it depends on, if we go like this, if we go to pH is 7 point, we know it's acidosis, so
pH
it's
is gotta be
The
normal.
math.
What's that?
pH should be
Math
normal,
says it's acid.
like 7.4 is what
Okay,
you
if
got
the
up.
pH is normal, then
Yep.
it's compensated.
It is
If
compensated.
you ever see the pH, okay, but again, to me, that doesn't work. In other words, that doesn't make sense. Those results don't add up. Because you've got
Alright.
one of them that's normal. Put it this way.
Yeah.
If I give you any question that's compensated, both of those will be abnormal, not just one.
Thank you.
Okay? If I ever give you an equation and I say, what is this? If the answer truly is compensated, more than likely, both of these values will be going the same way.
Thank you.
Okay, I need you guys to turn so we don't run out of time to page 380. Left-hand column on page 380, go down to where, it's a little over halfway, it says sources of error in collection and handling of blood gas specimens include the following. The first thing is the collection device. The second says the form and concentration of heparin used for anticoagulation. The speed of the syringe filling, maintenance of an anaerobic environment, means you can't let air get into it, mixing of the sample to ensure dissolution and distribution of heparin, and transport and storage time for analysis. Okay, so what I want you to know about this is, if we go up to the next column, first paragraph, it tells you that the proper sample, like I've got one that Respiratory gave me, this is a 3 cc syringe. You guys are used to holding a 10 or a 12 cc syringe, all right? These are going to be coated on the inside with heparin, all right? That heparin, I asked Dr. Berg, I said, the book tells like they really don't want you using liquid heparin because it can have a dilutional effect. Because what happens is you have this arterial blood in here, and then what happens is you squirt a little bit of that blood into the analyzer, and it gives you all these readings on bicarbonate, pH, partial CO2. It tells you all of that stuff, okay? But if you had excess liquid in here, all right, it dilutes the blood and it can give you an erroneous result. So more than likely, you're going to have to use a dry form of heparin, the powder. In other words, the very inner lining of this little syringe has you may not even be able to see it, but it's going to be lightly coated with a powder-like substance. That's heparin. So heparin is not going to be in a tube. It's going to actually be in the syringe you're using. This is your sample. You remember when I told you I worked at the VA? This is what they sent to chemistry department. It would be in a biohazard bag. Your arterial blood was in this little self-sealing 3 cc syringe. Remember, when they go into an artery, they may have it pulled back a little bit, but you know when you're in the artery because you don't have to pull back the plunger. It automatically is going to, all right, because of the pressure. Okay, so first full paragraph on the right-hand column on 380 says, in most instances, the ideal collection device for arterial blood sampling is a 1 to 3 ml self-filling plastic disposable syringe containing the appropriate type and amount of anticoagulant. Evacuated collection tubes are not appropriate for blood gases. While both dry and liquid lithium heparin are acceptable anticoagulants, the liquid form is not recommended because liquid heparin can dilute the sample and possibly alter the sample due to equilibrium with room air. Once drawn, the blood in the syringe must be mixed thoroughly with the heparin to prevent microclots from forming. Adequate mixing is also important immediately before analysis to resuspend the settled cells. And then over in the next column, it'll tell you the importance of maintaining an anaerobic environment, okay? You don't want to get any trapped air in the syringe. I mean, think about what we're measuring. We're measuring CO2 levels, right? So we don't want to have air bubbles. You don't want to have trapped air or anything like that in the syringe.
Glad we don't have to do
And then it tells you it's about exactly halfway down in the left-hand column on page 381. It says the best practice to avoid any of these aforementioned pre-analytical errors is to analyze the sample as quickly as possible. I have never seen a blood gas that was not ordered stat. Okay. So they want you to do this testing immediately. Let's do a couple of questions real quick. Page 382, number 2. Says the preferred anticoagulant of arterial blood gas measurements is blank in the blank state.
A.
A, good, A.
It's like, you know what, we're gonna focus on it.
Right. Every once in a while, that's what I see in there. Just
Let's go ahead and look at number 5. The normal ratio of carbonic acid to bicarbonate in arterial blood is which?
20 to 1 D.
Okay, that's a trick question. Okay, you're right. We talked about it in the book. Bicarbonate to carbonic acid is 20 to 1, but they're telling it to you in reverse.
Oh, it's 1 to 20, so it's
the
A.
answer actually is 1 to 20. You better put an asterisk by that one.
report on it. I mean,
Tricky.
Okay, let's do number 7. pH 7.37.
Yeah, that's the.
Somebody tell me what the rest, PCO2, what's that?
75,
75? What's the bicarb?
37.
37?
Yep.
Okay, so
Compensated.
PCO2 is 75, that's almost double, so we got an increase.
mhm.
Okay, and HCO3 is 37, that's also increased. Okay, so
Compensated.
Patricia, since I know that you're looking at this stuff a little bit dazed, let's walk, I want you to walk through it, okay?
Your method?
Do it any method you want. You know me, there's more than one way to do this, okay? So tell me what you're thinking about.
You can get the answer.
Well, I'm
That's all that matters.
thinking that the PCO2 is alkalytic. And I'm also thinking that the HCO3 is acidic. And the pH is normal.
Tell me
No,
which
pH is
answer,
not normal.
which answer will you circle out of A, B, C, or D for number 7?
pH
Off
is
the
normal.
results that you have.
Well, I know it's compensated, so I rule out C and D.
Okay, great. You guys hear how she just did that?
Yeah.
I am big on that, okay? Because when you take your registry, I do not
She
expect
said
you guys to know
the
every
pH
answer
is
to that
normal, so she
registry.
knows that
But
it's
I
not
do expect you to take the best educated guesses possible. So she just increased her odds of getting this question right, simply because she remembered that if the pH is in the normal range,
25%
it means
to 50%.
compensated, okay?
I rule out B, because they don't ever say non-respiratory.
Well, no, actually, I'm gonna make that part on you. Non-respiratory is the same as saying metabolic.
Okay.
What?
I think it's A.
So you think it's A? What does A say?
Compensated.
Compensated what?
Respiratory acidosis. Yeah.
Okay, I agree with that, but let's look at it and work through it real quick and I'll let you guys go. Compensated because the pH is normal, okay? Respiratory acidosis, the CO2 was almost double what it should be, right?
Mhm.
We're going acidosis because even though it's in the normal range, it is toward acid.
It's
You
closer.
agree, because it's 7.37? So what is the compensation mechanism? If it started out as respiratory acidosis, why is the bicarbonate also elevated?
The kitchens are compensated for the high acid content.
Great.
Yeah.
That's exactly it. That's just like this is exactly like the
The
example that we
kidneys
did
are
earlier.
compensating for the high acid content by pumping out more CO2.
Hydrogen
By
ion.
carb.
Well, it's pumping out,
Whatever it is.
it's pumping out hydrogen ions, remember the little
Yeah.
H with the plus sign?
Oh,
Okay, you're gonna
got
void
that.
that out in urine, but you're gonna reclaim the maximum amount of bicarb possible.
Good. So it's A. All right.
That's all I got.
Thanks,
Good.
sir.